interesting system, and you'll see why. First thing I want to do is, if I want to solve this, use Gaussian elimination. Now you can use Gaussian elimination, you can use Gauss-Jordan. I'm going to use Gauss-Jordan, right? So forget about what this says. I want to go into reduced row echelon form. That's what I want, because that's where I get my answer. So I'm going to just go straight there. And I'm going to use my calculator. Let me write the augmented matrix for this, because I need to know how to do that. So down the X column, down the Y column, it's already organized for me, down the Z column, and then my constant column, oops, and then -5, 0, and 1. Okay, so here's my augmented matrix. Now I want to put it in reduced row echelon form, and I'm going to use my graphing calculator to do that. So let me input this matrix into my calculator. This is another 3x4 matrix. So let's clear everything out. Let's go back to matrix. Now, you don't technically have to clear out this matrix if you don't want to. If you don't need it again, then you can. If you need it again, leave it in there and put your new matrix in matrix B. I'll just put it into matrix B just to show you how you can input multiple different matrices. So I'm going to put this matrix into matrix B because I already had something in A. Enter, and I'm going to tell it it's a 3x4 matrix, 3x4 matrix, 3 rows, 4 columns. And then I'm going to go across the top, and my first row is 1, -2, -1, -5. 1, enter, -2, enter, -1, enter, and 5. Go down or across row 2. 2, -3, -1, 0. 2, enter, -3, enter, -1, enter, 0. Row 3, 3, -4, -1, 1. 3, enter, I forgot what I said, -4, -1, 1. I'm going to double check it again after anyway, but -1 and then 1, enter. So let's see, double check my matrix, make sure it matches. So down 1, 2, 3, -2, blah. This matches, this matches. See, -5 should be up there. So I made a mistake here. This should be a -5. Okay, always double check because you don't want to do the wrong thing, right? You don't want to solve the wrong problem. Okay, my matrix B is in now. It's in matrix B. I have to remember where I put it. So now let me go back to my home screen, nice clear screen. And I want reduced row echelon form. So second matrix, see B is in here too. So, you could see that they're both 3x4. So just, if you want, write down where you put it. I know that I put it in B, or remember where you put it, so you don't, go with the wrong matrix. Down to reduced row echelon form, enter. I have to tell it which matrix, and this time I want matrix B. So back here, number 2, matrix B, enter. I want reduced row echelon form of matrix B, enter. This is a very interesting matrix that just appeared. Let me copy it down. Reduced row echelon form was 1, 0, 1, 0 across the top. 0, 1, 1, 0. 0, 0, 0, 1. Does that look like reduced row echelon form?
No.
I would say no. And I would say the reason is because reduced row echelon form should have 1s down the diagonal, 0s in the lower triangle, and 0s in the upper triangle. But what do you notice? Now, if I were to convert this back into a system, let's go across the top. 1x plus 0y plus 1z is equal to 0. Go across row 2. 0x plus 1y plus 1z is 0. And then what the heck does this say? 0x plus 0y plus 0z, 0 is equal to 1. What kind of system is that? Look at this. If you recall, back in systems of two variables and 2 equations, when you have a false statement algebraically, you go through the process and you get a false statement, right? You have no solution. There is no solution to the system. No wonder it can't go into reduced row echelon form. There is no solution. There is no such point of intersection where all 3 planes intersect. Point or line, they don't all intersect at the same place, and therefore there is no solution. So you know, if you see in your matrix a row where you have all zeros and then a number here on the other side of the line, then that implies that you get a false statement. You know, 0 does not equal to 1. That's not true. So therefore, there is no solution to the system. So this is what it looks like when you're solving using matrices and you get a situation where you have no solution.